So, so determine convergence or divergence of the series negative 1 to the n plus 1, 1 over n. Okay. So for the alternating series test, all you got to do is check number 1 is the limit of the sequence, the non-alternating part, equals to 0. Yes, right? Number 2 is 1 over n plus 1 less than 1 over n.
Yes.
And if you're not sure, is n less than n plus 1? Same question, right?
Yes.
And that's true for all n greater than or equal to 1, correct? So check. So therefore, the series with the alternating piece converges by the alternating series test. It's pretty straightforward, right? So if it passes both 1 and 2, because if you think about it, it's actually kind of interesting, right? Because we know 1 over n without the alternating does not converge, right? Because that's a p series where where p is equal to 1. But if you attach the alternating part, then you can use the alternating series test and show that, yeah, this one does converge because it's alternating. But the absolute value version would not actually. If you can find it visual.
Is it 0?
Yeah, it's going to be 0. Let's show at work, right? Let's see here. Actually, sorry, I'm supposed to use the alternating piece. Well, do I? No, we don't. Yeah. Now it looks like it's going to be 1 actually. Well, let's show it'll work. To show it, remember I said you just divide every single one by the highest power, right? Every term, which gives you 1 plus 1 over n over 1, which is going to be equal to 1, right?
Yes.
So this piece goes to 0, but the rest doesn't. So it fails number 1, right?
Yes.
So we will not need to do the second test. If it failed one, it failed altogether, right?
Yeah, you have to pass both. If not, you cannot. The alternating series test failed. So we cannot apply the alternating series test. That does not mean it diverged. We don't know what happened. We have to use something else. So what we can do is take the limit. Remember, we have the diversion test. You can check that guy. Since this limit wasn't 0, the diversion test says if you have a limit that's not 0, then the series diverges if the sequence is not 0. So we're going to take the limit of this sequence with the alternating piece and see what happens, right? So let's use the alternating, the divergent test, right? On this piece, actually. So the sequence part. Now, if we take the limit, it's going to turn into this, right? Except it has a -1. Isn't this the exact same thing?
Yes.
So what's going to happen is what? The limit is equal to 1 for this piece times the -1 to the n plus 1. So it's going to keep cycling forever between 1 and -1, right? It's going to be either of these values over and over again, right? You see what I'm saying?
Yes.
Yes.
So since it doesn't stay on one value, that means there is no limit. So since the limit of the sequence is not 0, then the series diverges by the divergent test. So if you can't, remember that was a couple of rules ago, right? Let me see if I can find the notes. I think that was 9.1 or no, 9.2. Right, we said that here it is. The nth term test, or the divergent test, if the limit of the sequence is not 0, and our limit was 1 and -1 over and over again, meaning the limit does not exist, then the series of this sequence, the summation of an, diverges using the divergent test. So diverges. Is there any questions on number 2 here? Is that okay?
Yes.
Okay. One moment. Okay. Let's go to the next question. Here's another theorem. I don't know the number. That's from the old book. The theorem, suppose that the limit of a sub n is equal to 0 and n goes to infinity. And 0 is less than an plus 1, which is less than an. In other words, they mean that an is decreasing, right? For all n greater than or equal to 1. Then the alternating series tests, series, no test. The alternating series n equals 1 to infinity of negative 1 to the n plus 1 of an converges. Wait a second, did I write the same crap again? No. Okay, so that's the same, but they're gonna ask for an error approximation. Okay, I got scared for a second. I thought I was repeating myself. Sorry. That was true. So then extra part is to some number s. And the error in approximation approximating, not approximation. Approximating s by the nth partial sum a sub n satisfies s minus s of n less than or equal to an plus 1.
That's the absolute value, right? That's what the absolute value of S minus S of n.
Yeah, s minus s of n.
Yeah, absolute value equal an minus 1 or an plus 1.
An plus 1.
Yeah,
So
thank you.
this is less than or equal to, actually. Okay. And for what that means, right, in case you're wondering what the heck that's saying. So for example, if I have some number s minus s5, right, then that would be less than or equal to a6, the sixth term. That makes sense? That's what the numbers mean. So basically that would be saying that S minus A1 plus A2 plus A3 plus A4 plus A5 are all, let me write it somewhere else. There's not enough space here. I don't know why I'm jamming it in the corner for no reason. Okay. S minus S, let's use 4. That would be less than or equal to A5. And what I mean by that is the partial sum S would be minus all the sums up to 4, A1 plus A2 plus A3 plus A4 would be less than or equal to A6. And S, capital S, is the total sum to infinity. So the entire sum minus some number n that you choose, some partial sum that you choose, is less than the next term. Okay. So let's do an example here. Okay, the sum as n equals 1 to infinity of negative 1 to the n plus 1 times 1 over n factorial. So for this one, what we're going to do is approximate the sum by the 6th partial sum and then estimate the error. Okay. So we're going to do the 6, but in order to do so, we need to first check if it's converging, right? How do you find the sum? If it doesn't converge, that wouldn't make any sense. So let's check real quick. So number 1, the limit of the sequence is 0, right? That should be clear. Do you guys agree with number 1?
Yes.
Number 2, is n factorial smaller than n plus 1 factorial?
Less than or equal n plus 1
Mm-hmm.
factorial. Okay, Carl.
It is, right?
Yes.
So then that means that the reciprocal would satisfy our condition, right? Increasing. Now the question begins. Approximate the sum by the, I don't know how I wrote there. by the 6 partial sum and estimate the error. Okay, so S6, that means you add up the first 6 terms, right? And then you subtract it by the total sum. And see what that is. Okay. So S6 would be the first term minus the second term plus the third term minus the fourth term, right? Doing the factorials plus, yeah, minus, okay. So that would be about, I'm gonna skip the fraction step because just to save time. I believe you guys know how to do fractions. In a calculator, that would be 0.63194. So that's the 6 partial sum. They want to know the error of the 6 partial sum. That's what they're asking for. So what you're going to do is say, well, S minus S6, the error will be less than A7. Well, what is A7, right? Well, that would be S minus 0.63194, which is less than or equal to 1/7 factorial, which is 5040, which is about, yeah. So this right here is the error that they're asking for. Any questions on this problem? That's pretty much it for 8.4 is, can you use the alternating series check test by checking those 1 and 2 conditions? And then if they ask you to find the error between a specific partial sum, then this is what you're gonna do. That's it for that section. Let me check our schedule. I don't know where we're supposed to be.
Professor, at the end of the class, I have just one problem, 1 or 2 from the homework I need us to ask you about.
Okay. Did you pick the easy ones?
No. It is just summation. How to do summation? Not even get the diversion or conversion. I just have two
okay.
summation. I want to get to know how to do the summation of those two to get the answer.
Okay. Yeah, we can figure it out. Okay, we're in week 11.
So,
Okay.
are we having just one exam before the final?
Yes. The last chapter 10 will
Oh, the chapter 10.
probably be I don't know about chapter 10 yet, but I'll probably give you some homework on it, but not a test.
Good. Very good. Thank you. Appreciate it.
Yeah, because there's a lot already, but the final's gonna have everything, so it's gonna be most likely, but I haven't thought that far ahead yet. Let's see. Yeah, okay. So we need to do a couple more sections then.
you have all
What's that?
those pretty much same things.
Yeah, 9.5 is absolute convergence. And the ratio test. Oh, also, and root test, I forgot. So ratio and root were my favorite because they're pretty straightforward. 8.5 is not too bad. Let's see. So let me give you the absolute convergence. So the theorem says if the series n equal 1 to infinity of an converges, then the regular version converges as well. One second. Okay. Example 1. Determine whether, oops, got my H. determine whether each of the series is convergent. Or divergent. Classify any convergent series as absolutely or conditionally convergent. All right, so what you do is you take the absolute value and then you check if it converges. If the absolute value does not, then you check the conditions. If the conditions pass, then you say that the series converges conditionally. But if it converges with the absolute value, then it's absolutely convergent. So that's what we got to do for each one. So we're going to do a few of these. Part A, or also it could diverge and it doesn't matter, right? I forgot. That's option 3. All right, so does this converge absolutely or conditionally, or does it diverge? So what you do is take the absolute value, right, and check them, and check if this converges. Because then we can say, okay, then so does the alternating piece. So the absolute value, so check if the absolute value of A sub n converges. So here we go. So then you look at this and you're like, okay, well, I don't know what test to use, right? But whenever you, so we're getting to the point where they're not telling you what test to use anymore. You need to figure it out. So the first test you should always try is the diversion test, because if that one works, if the limit is not 0, then the series diverges and we're done. Right, but you still have to check the 2 conditions. So, oops. Let's use diversion test first. So the limit of n factorial over 2 to the n, what is that limit? What's faster? N factorial or 2 to the n when it comes to growth?
2 to the n.
What is n factorial?
It's n times whatever.
Right?
It would be every number multiplied leading up to whichever factorial you choose.
So if I choose 100,000 and I multiply all the way down to 1, would that be bigger than 2 to the 100,000? Because that would be just a bunch of 2's. This thing would be a bunch of numbers all the way down to 1,
Point taken.
right? So the top is bigger. This limit is infinite. So since divergent test says, since the limit of the sequence is not 0, then the series diverges. So we're done with part A. We don't have to check the two conditions because that is one of the conditions, right? Divergent test is technically one of the conditions.
Hmm.
So we'll move on to question B. You guys have any questions on part A?
No.
Okay, part B. I wrote that right. No, sorry, I was writing the same one. Shoot. There it is. The negative 1 to the n over square root of n. So first thing,
The top is bigger.
the what's bigger?
The numerator is bigger than the denominator.
This is just negative 1 to the n.
Oh yeah, I'm thinking the value of this should be always be bigger than the denominator, right?
Not necessarily. I mean, this one's always going to be 1 or negative 1 forever.
Oh,
This
yeah,
one-
yeah.
This
Got it.
one
Right. I'm sorry, I got
will go to
confused.
0. The limit will be 0 for this guy. So the first thing we do is take the absolute value, right? So let's look at the limit, sorry, the series. Let's look at this guy. What kind of series is this? What test would you use?
I mean, we could probably just take the limit right now and find the fact that it will equal 0. Which
Yeah,
would
that
mean
would.
that it
Satisfy the first condition, right? But it's a certain type of series. Do you remember it? If I wrote it this way, does that help? 1/2.
P series.
Yeah, it's a P series type, right? That P series, what is this type? The P is less than 1. So what does that mean?
I believe it diverges.
Yeah,
If P is
technically.
greater than 1, or excuse me, sorry. If P is greater than 1, it converges, and if it is less than or equal to 1, it diverges.
Right. Yeah, that's correct. So this guy technically diverges, but it doesn't really tell us anything about the alternating piece, sadly, because the theorem says if this guy converges, then this guy converges. It does not say if the absolute value diverges, which is this one, right? Then the other one diverges. So this doesn't really tell us anything, but it is good to remember what type of series this is. So since this does not converge straight up, I have to check the conditions. So that's how you know, start doing the conditions, because this did not converge. So is the limit of the sequence equal to 0? Yes, right? And is the square root of n bigger? Sorry. Yeah, smaller. Sorry, smaller. If that's smaller, then this, okay, writing the wrong thing. And this would be true. It's decreasing, right? So this series converges conditionally because it passes both conditions. But it does not converge absolutely. Is there any questions on part B? Make a note for you here. Since this is a divergent P series, then this, then we check the conditions. So is this question okay?
Yeah.
All right. Sorry, I was going to pick another question. So once you do the absolute value, you no longer have the -1 alternating anymore. So look at this guy. First thing you always do is the divergent test. Meaning you take a limit of this guy and check if it goes to 0. And it does, right? So that means the divergent test told us nothing. But if I need to, then it did meet the first condition. But we're not going to do condition. We don't do the condition stuff until we know for sure that the absolute value does not converge. Okay, that's the order, right? First, you verify what the heck the absolute value is doing. If it converges, then you are done. If this diverges, then you check the conditions. So far, I have found nothing. So let's try a different test. So the test I'm going to use is going to be, let's see here, it's a good one. I think comparison might be best. But since we already checked number 1, let's go ahead and do number 2. Is ln of n bigger than ln of n plus 1? Which one's bigger?
ln plus 1.
Yeah, it should be the other way, right? Should be this way.
Right.
So we do the reciprocal, then it flips over, which shows that it is decreasing. So we do know it converges conditionally, but we need to verify that it doesn't converge absolutely before we stop. So this right here shows conditional convergence. Sorry, my mind's a little distracted today. Okay, so what a good trick to remember is when you see ln as part of your sequence or as the series, the one you want to use most of the time is going to be comparison test. But the trick is, what do you compare it to? And you choose the 1 over n. So let's use comparison test to see if this converges absolutely. So AN is going to be the original. The BN that I will choose myself will be this guy. Remember that the series of 1 over n is a divergence P series, right? So we talked about earlier. Which means that if this one is smaller than this guy, and this one diverges, then so does this one. So let's find out. Which one's bigger? Is n bigger than ln plus 1?
No.
No, let's graph it, right? Convince ourselves. Because we have to know what the functions look like. Let's see here. Y equals x. Y equals ln x plus 1. Which one grows faster?
N.
N, right? So the bigger one is this one, right? N. Now, if I take the reciprocal, would be smaller, right? So since 1 over n series diverges and Bn is less than An, then An series also diverges. By the direct comparison test. That's what I used here.
Thank you.
But that doesn't tell us anything, does it? Because this is the absolute. We're looking at this guy, right? So since this diverged, then we know nothing about this guy. But we know it. All we know is that it is not absolutely convergent. That does not imply divergent. What it does tell us, though, is to look at the conditions. So we can now say, this means, so this is the answer here. This means that the series base of n is not absolutely convergent, but it is conditionally convergent. By the alternating series test. So this is the actual answer. There's a lot of theory here. Is there any questions about this? Part C. You guys okay?
Yes, sir.
Yeah, just still writing the notes though.
Okay. Yeah, no rush. Okay. All right. So we talked about, so this is the weight 9.5. We talked about the absolute conversions and conditional conversions. Now let's talk about the ratio and root test. It's a lot of tests. I don't know if you noticed that. Isn't it nice that you don't have to memorize this stuff? 'Cause my teacher made me memorize this stuff. It's not cool. All right. Ratio test. Given. I guess it's blurry. All right. Given the series n equal 1 to infinity of a sub n with a sub n not equal to 0 for all n, suppose that the limit as n goes to infinity of an plus 1 over an is equal to L. Then, number 1 is, the following is true. Number 1, if L is greater than 1, or L is infinite, the series diverges. Number 2, if L is less than 1, the series converges absolutely. Number 3, if L equals 1, then there is no conclusion, you know nothing. Gotta do something else. Example 1. I don't know what example we're on anymore. Determine the convergence or divergence of the following. All right, so 2 to the n over n factorial. So whenever you see a factorial, you want to use alternating, or you want to use the ratio test. So let's use the ratio test. So an is equal to 2 to the n over n factorial. An plus 1 is equal to 2 to the n plus 1 over n plus 1 factorial. So what is the limit of an plus 1 over an as n approaches infinity? So that would be equal to the limit Right, so I'm going to put this one on top, right, an plus 1, and this one on the bottom, which means you would flip it over and multiply, right? I skipped an algebra step here. I'm going to show you a little bit of algebra on the next one, just in case. This would be 2 to the n times 2 over n plus 1 times n factorial. See, I can separate the 2n plus 1, right?
Yes.
And I can reduce the factorial by 1. Now notice what's going to cancel, right? Factorials are gone, 2 to the n is gone, leaving me with,
2 over n plus 1.
yeah, what is that limit?
0.
0. So according to condition 2, what does this mean?
It divergent?
Number 2.
It converges.
Oh, oops, wrong thing.
No, it's okay.
Convergence.
Since the limit of an plus 1 over an as n goes to infinity is equal to 0, which is less than 1, then
We would have
the
put that.
series
Thank you.
converges absolutely.
We don't have to put by the ratio test.
Yeah, we should. Okay. So the cool thing about this is if you see an alternating piece, for example, let's say back here. Where is it? Yeah, part A. Part A, you could have done the ratio test. If this was an infinite, you could have said, you know what? Let's just do the ratio and see what happens. On the other one, maybe not. But the ones that look like geometric, you could technically. And running out of paper. Okay, let's do another ratio test. Assume that all the questions are converge or diverge. That's pretty much the whole chapter. So let's do the ratio. So an is n squared, 2n plus 1 over 3n. An plus 1 is n plus 1 squared times 2 to the, what would that be? N plus 1 plus 1. Yeah. Let me just write it down here because I don't have space. N plus 1 squared times 2 to the n plus 1 over 3 to the n plus 1, which will simplify when we start doing the limit. So let's find out what the limit of an plus 1 is doing. So put this guy first, n plus 1 squared times 2n plus 2 over 3n plus 1. Oops, divided by the an, which would be multiplied by 3n over n squared times 2n plus 1. Right? Okay, let's show some work, some algebra, so you can see what happens. So this would be just n squared plus 2n plus 1, right? Who cares about that piece? Next part would be 2n times 2 squared, right? Times 3n we're separating the pieces. 3n times 3 times n squared times 2n times 2. Right. I broke down this piece here, and I broke down the 2n plus 2 and the 3n plus 1. So now let's cancel stuff. So these are gone. Those are gone. One of these 2's are gone. So we're left with the limit. This n goes to infinity. So n oh yeah, one of the 2's are gone. So I'll leave it, put a 1 there so I don't forget. I'll put it over here, I guess. Down here we have a 3n squared left. Yeah. What is this limit?
So 2 over 3.
Infinity.
2/3. Because the degree of the top is the same as the degree of the bottom. So you take the coefficients.
Oh, okay, got you.
So what does rule number 2 say? For ratio.
It's less than a 0, which converges.
Is less than 1. So since the limit of the ratio of an plus 1 over an is equal to 2/3, which is less than 1, then the series a sub n converges absolutely by the ratio test. Any questions on this problem? All right. Let's do the last theorem and one last example, and we'll be done. Root test. Root test and ratio test have exactly the same conditions, but you use them in different scenarios. They're similar. So given a series a sub n, suppose that the limit of the nth root of a sub n as n goes to infinity is equal to L, then the following is true. Number one, if L is greater than 1, then the series diverges. Number two, if L is less than 1, then the series converges absolutely. Number three, if L is equal to 1, there is no conclusion. You have to do a different test. See if I can do this in the space here. Determine convergence or divergence of this series. So what you do is take the limit of the sequence, but you do an nth root of everything. Which cancels all the n's. This will leave you with the limit as n goes to infinity of e squared over n, which would be equal to 0, right? So since the limit of the nth root of an as n goes to infinity is equal to 0, which is less than 1, then it converges. Absolutely. By the root test. All right. Let me give you some strategies as to what test to use when, because I know right now that's the hard part, right? Strategies for testing series. Number one, use the divergent test and check if the limit of an is equal to 0. If not, the series diverges. That's the first thing you should be checking. Number two, if this doesn't help, if the limit is 0, then check what kind of series it is. Is the series geometric, P series, or alternating? So those are easy to spot. And if they are, then use the appropriate test. Number three, if it's not one of those, and it didn't diverge to begin with the divergent test, can the integral test, root test, and ratio test be applied? Another thing you should look for is, can the series be compared favorably to one of the special types? If you notice that you could do a comparison to an easy like P series or something, or if a limit comparison works, then go that route. Those are the things I want you to ask yourself.
I have a question here.
Yeah.
So the first point I'm trying to use the divergent test. If it n equals 0 means it diverges, right?
If the limit is not 0.
If it's not 0, it diverges, right?
Right.
So if it diverges, I go to the 2 or I don't have to go to 2?
If it diverges, you're done.
I'm done. Okay.
But if the limit is 0, then the test doesn't tell you anything.
Okay. Got you.
So then you go on to 2 and check, okay, is it one of the special types, like the geometric, the P, or alternating? Those are easy to see. And then use the appropriate tests. If it's not any of those, then check, okay, can I use a root or ratio? And if I can't figure it out, then maybe I should consider integrating. Integral would probably be the last, for me, I think it's the last case or worst case scenario.
For all of us.
I do not recommend that one unless you have no choice. If you can't figure it out, start integrating. Like if you're on a test and you can't figure it out, try the integral. Comparisons is really easy if you can find a good comparison. So that's the hard part, is finding it and choosing it. Okay.
If we're done, I can say my questions for the homework.
Sure, let's go real quick because it's almost time to go. What's your question?
Okay. The first question is summation of n equal 1 to infinity. Like, no, n equal 1 is the bottom, yes, to infinity of 12 over n and then open bracket n plus 2 close the bracket. So n multiply n plus 2, that's it. How to get the answer of this summation in matter of summation, like how to solve it?
They want to know the total sum?
Yes.
So I would pull out the 12 first. This is just a number. And then I would try to see if I can apply any of the formulas. What section was this from?
I think 9.3, 2 or 3.
9.2 or 3, let me check. All they wanted was the sum?
Yeah, to get the sum, the answer of the sum. And I got the answer, but it's not, I don't know the steps.
What was the answer?
9.
9? Okay. We'll think about that in a second. I think this might be. So they want the sum, correct? Not convergence or divergence.
No, the sum, the answer.
It says find the sum of the convergent series. That's what the question is.
Oh, okay. What section was it?
It's 9.2.
9.2. Let me see.
About question number 4. Well,
Oh, I see. Yeah, I think this is a. I think you have to do partial fractions on this guy first to separate this. And then you try to find a pattern which will then converge to your sum. So all you have to do let's try finding a few terms. Maybe that'll help. We'll ignore the 12 for now. So S1 would be let me put there we go. S1 would just be 1 over 1 times 3, so that would be 3, right? S2 would be 1/3 plus, I don't think we should do yeah, I don't think we can see the thing that easily. Into the 1/2, the 1/8. Three. No. 2 would be 4. Yeah, that's right. 8, but it's not clear. Not without the partial. Not without the partial fractions. So what they do is they separate this and solve for A and B.
isn't that minus? Looks like
What's up?
it says 1 A over N minus B over N.
Well, we don't know what A and B is yet. It could be minus.
Oh,
So you got to find the letter numbers first. So solve for A and B. It probably will be. We'll end up with A times N plus 2 plus B times N, right? Equal to 12. So if I let N be 0, I would get 2A equal to 12, which would be 6, right? if I let n equal -2, this would be 0. So I'd have -2b equal to 12. So b would be -6, right? Okay, so then we have 6 over n minus 6 over n plus 2. Okay, I need more space here. What do we have on top? 12?
N plus 2.
Yeah. Okay. Then we separate that as 6 over n minus
6
this,
over n
right?
plus 2.
Okay. We can pull out the 6 in front. Which will leave us with 1 over n minus 1 over n plus 2. So now if we do the partial sum approach on this one, it'll be more clear. So S1 would be 1 minus half, right? No, a third, which is 2/3. S2 would be 1 minus 1/3 plus 1/2 minus 1/4, which is really what? 2/3 minus 1/4 would be what? Let's leave it like that for now.
Five over 12.
Yeah, you seeing the pattern?
Yeah.
Right? This one would be minus 5th. So let's just go to n now that I see it.
Wouldn't it be +2? Which goes on?
Oh.
Wouldn't it be 1 over n plus 2?
Yeah,
On the side.
hold on.
It's 1 over n minus 1.
Yeah, the
Minus-
last one will be
Oh,
right here.
okay. Yeah.
Okay. So eventually you see that all these cancel out, right? So the 1/3's gone. The 1/4's gone. They keep on canceling, leaving you with 1 plus the 1/2 minus the 1 over n minus 1 minus the 1 over n plus 2. Then of course there's that stupid 6 in the front, right? But who cares? You take the limit of the partial sum, you will get 6 times 1 plus 1/2 minus all this nonsense. leaving you with what?
6.
And the 12 that we took away at the very, very beginning, we ignored this one? At the
No.
very beginning?
No, we use it to solve for this.
Oh, yeah. Okay. Yeah, I'm sorry.
No,
I
that's
lost.
okay. Yeah, that's
Okay,
kind of
thanks.
like, I
Thank
think,
you.
I believe this is a telescoping kind of series. We didn't really talk about that one, but I
The
think,
second one is
Huh?
much easier. Much
okay.
easier than this one, but I will say it's the summation of n equal 1 to infinity of 1 over 7 to the power n.
N squared?
No,
Or,
it's
2n, 2
7,
to the n.
no, 7 to the power n. 7 to the power n, not 2.
Oh, 7, I'm sorry.
7. Yeah, you need to work on your English. No, I'm kidding. 7 to the power n. Yeah, and this one, the answer was 1 over 7 ln 7. That's it. 1 over 7 ln 7. I don't know how good.
What were they asking for?
It confirms the integral test can be applied as conversion or convergent or divergent. And what is the answer of the integral from 1 to infinity, 1 over 7 to the power x dx. So yeah, the problem maybe this not the one that I gave you. It is the integral from 1 to infinity of 1 over 7 to the power x. Integral from 1 to infinity of 1 over 7 to the power x. And it equal 1 over 7 ln 7. 1 over 7 multiply ln 7, yes.
Okay. Here, let me give you the formula that you need. Here, let me. Usually we usually use a formula, but it's this one here. The formula is the integral of a to the x dx is equal to a to the x over ln a plus c. So we have the integral of 7 to the negative x. Which
A
will
of x over L, A of x over ln A. What is this in the fraction? What is the fraction part of the formula? Yeah, the
ln of a right here.
of A. Okay, got you.
So it'd be ln 7 on the bottom.
Right.
Now, since ours is negative, we can let u equal negative x. Du will be negative dx. So negative du is going to be dx, right? So the integral
Right.
of 7 to the u, the negative in front, du, is equal to 7u over ln 7 plus c, but we have a negative, so the negative 7 to the negative x over ln 7, and then you do your limit stuff. So we would have negative 1 over 7 to the x ln 7 from 1 to infinity, right? I'm being a little improper, but you see what I'm saying, right?
Yes.
Supposed to say b, technically. B. With the limit, b goes to infinity. So you take the limit, so you have, what? Negative 1 over 7b ln 7 minus a minus right? This goes to 0. You end up with 1 over 7 ln 7.
Thank you so much. It was very hard.
Oh, no problem. Yeah, you just have to remember that formula. But if you want to see the derivation for fun, let me show you. This is how you derive it. You use the definition of exponentials, right? So you change this to e to the x to the ln a, and then you use your algebra rules to find it. But most of the time, I just remember this is equal to this, and I'm not going to worry about it. I'm not going to derive it every single time. So just use the formula I gave you, but this is how they make it.
Right. Thank you.
You guys have any other questions?
Thanks
No,
a lot.
not for me.
What's up?
Oh, I was like, no questions right now. Just
Okay.
Thank you so much.
All right, guys. Well, I'll see you Wednesday. And let me know if any homework closes, because I know you have a lot, so I can extend it.
I got a question, but it's not pertaining to this. It's pertaining to how to type it out on the in the homework. I worked
On
it
the
out.
homework,
It was I'm at 9.10.
mhm.
It's number 3.
9, 10.
Number 3. I
Is that the McLaurin and Taylor series? Is that where you're
yeah,
at?
the Taylor series, yeah, Car Taylor series. I
Okay.
I came up with the answer, but it's asking to put it in a summation, and that's
Yeah,
what I'm having.
That's the hard part, trying to find the pattern to figure out
I
what the hell
figured it
SN is.
I figured it out, but they wanted the way I figured out the answer is not what they want to be put it in the answer box. They want it in a summation.
What number was it?
Number 3,
The cosine X?
cosine x, where c is where the center of c is equal pi over 4.
Okay. Here, let me show you what it looks like.
Because this is the last. I don't know if you can see my my homework, but this I put square root of 2.
Should look like this. How did you plug it in?
Oh, I didn't put it like that. I have it's the square root of the radical of 2 over 2,
Mm-hmm.
and then I have brackets 1 minus raised to the n times n plus 1 over 2 times.
Yeah, I think they
then-
put the 2 down here, it looks like.
Well, I have the 2 on the bottom, but it's not. I don't have it like that. I didn't put I didn't type it in like that. That's all.
Yeah, I think it's being picky. I don't think you're probably correct, especially if the algebra is the same. It might just be being weird about it.
It's the same answer. It's just that I see where you have the 2 next to the 2n factorial. I have just the underneath the radical. It's a square root of 2 over 2
I see.
then-
So
times the same answer that you got there over n over factorial. So I don't know. I'll put it like that. And
okay,
that
yeah,
was-
just change it. I mean, I think you're right. So, do you want to write it down?
I'm gonna write it down real fast.
Okay.
Professor, 9.5 and 9.6 are past due. The
Okay.
homework 9.5, 9.6, why we didn't take them yet?
Okay, I'll open those up right now.
Thank you.
Okay.
Got it?
Yeah. Yeah, I got it. I was just trying to figure out how to put it in there. It's just real picky. When it comes to this section right here, they're real picky on how they want to put it in there.
I got you. Yeah, just don't worry about it. I mean, on the exam, I'll know what you mean.
Okay.
That's good. You're very ahead.
I'm trying to get ahead so I can go back and practice all the ones. I'm putting stars by the ones I'm having a lot of problems with from all the
Gotcha.
assignments. So I'm trying to get so I can practice all this stuff.
I see. Let me change the dates. Don't forget.
Okay. The test. When would those be? For us to look at to see how bad we did.
Shoot. Yeah, I'll have those. Well, tomorrow I'm gonna be free all day, so I'll have those ready by tomorrow night.
You'll be tutoring tomorrow night?
Yes, I will be.
If I have any questions,
Okay.
I can ask you.
Yeah, that's fine.
Okay. All right. Thank you, Mr. Doug.
All right, see you later. See you Wednesday.
Are you gonna post the notes up?
Yeah, I'm gonna try to do that as soon as possible.
All right. Thank you.
Today, November 8th. Okay. All right, so I reopened 9.1 up until 9, wherever we stopped.